How's it going today, YouTube? Today we're going to be talking about how to find arc length and find the area of the surface attained by finding that arc length and rotating that curve about the y-axis. So today, for my example problem, I have y equals x to the fourth over 16 plus 1 over 2x squared within the bounds 1 is less than or equal to x, which is less than or equal to 2. Now, to start this off, you usually want to write down your formulas first. So the formula for arc length equals L, which is arc length, the integral from a to b, radical 1 plus f prime of x, second derivative dx. Or, to make this easier for those of you who are more familiar with Leibniz notation, it's arc length equals the integral from a to b, 1 plus, and then now we can write dy over dx, second derivative dx. Okay, so the first step we want to do for this problem is to find the derivative. So we get dy over dx equals the derivative of that function, which is x cubed over 4 minus 1 over x cubed. Do some algebra and simplification. We get that equals x to the sixth minus 4 over 4x cubed. Now that's just our first derivative. We got to find the second. Now, if you remember in the formula, it is 1 plus our second derivative. So at this point, I like to write 1 plus, and then our dy over dx second derivative, which equals 1 plus x to the sixth minus 4 squared all over 16x to the sixth. Now we can simplify this to make it more clean, which gives us 16x to the sixth plus x to the 12th plus 16 minus 8x to the sixth, all over 16x to the sixth. Simplify even more. We get x to the 12th plus 16 plus 8x to the sixth, all over 16x to the sixth. We can factor the numerator into x to the sixth plus 4 squared, all over 16x to the sixth. Divide out a 4 and some x, and we get x to the sixth plus 4 all over 4x cubed, which, as you remember, already equals our radical 1 plus dy over dx second derivative. Now, with a second derivative, we can just use this and plug it into our formula. So we get arc length L equals the integral from our bounds 1 to 2 radical 1 plus dy over dx second derivative dx. So that is just the integral of that, which is x to the sixth plus 4x cubed dx. Remember, we got this because it's the second derivative of our function. So we can pull out 1/4, make it easier. So we get 1/4 to integral from 1 to 2 x cubed plus 4 over x cubed dx. Take the integral, we get 1/4 x to the fourth over 4 plus negative 2 over x squared, evaluated at 2 and 1. So we get that equals 1/4. Doing our evaluation, we get 4 plus a negative 1/2 minus a fourth plus 2 equals 1/4. 6 minus 3/4 equals 21/16. So our arc length is L equals 21 over 16. Now we're not done yet, because part B says to find the area of the surface obtained by rotating the curve in part A about the y-axis. So in part B, same as part A, you want to start by writing down the formula. So the formula for surface area is S equals the integral of A to B, 2 pi f of x, radical 1 plus f prime of x, derivative dx. Now, we can also use the Leibniz notation to simplify this into S equals the integral of A to B, 2 pi y, radical 1 plus dx over dy squared dx. And we have also a special property because this is in a certain form of g of y equals c less than or equal to y less than or equal to d, we can write this formula again as s equals integral of 8b to, c to d this time, 2 pi y, 1 plus dx dy. And then finally, we can also write this as surface area equals the integral of 2 pi x dy, or ds, sorry about that. And this is referring to the rotation about the y-axis. If it was about the x, it would be 2 pi y ds. Okay, now, this is going to be pretty easy because we already found what our 1 plus dx dy was from the part A. So we get surface area equals 2 pi, because we just, you can pull that out and make it a little bit easier. The integral, 2 to 1, those are our bounds, which were the c to d from the original. And then we just plug in, this is the x, we have x6 plus 4 over 4x cubed from our original equation, dx. Now we can divide by a 4x, which will give us a 1/2 pi integral from 1 to 2, x to the 6 plus 4, x squared dx. We can reduce this, so we have 1/2 pi integral from 1 to 2, and then x to the 4th plus 4x to the negative 2 dx. Now I can integrate. We have 1/2 pi x to the 5th over 5 minus 4x to the negative 1. Integrate at the bounds, which are 2 to 1, which gives us 1/2 pi 32/5 minus 2 minus 1/5 plus 4. Do some math. We get 1/2 pi times 41/5, which equals 41 pi over 10. And your surface area for this particular curve over the y-axis is surface area equals 41 pi over 10. And there you have it, folks. Have a nice time, and I'll see you next time.